Assalamu alaikum wa rahmatullahi wa barakatuh. Hello everybody. Today inshallah we will start the first class in the course TE360, which is Electric Energy Engineering. This course شباب is an introduction for electrical machines and drives and for power system. So it will mix between the basics of electrical machines and power system. The course contents will be as follows. We will start with a review for three-phase circuits and also for single phase. We'll start with single phase first until finishing three-phase circuits. Then we will discuss the magnetic circuits, and these magnetic circuits are very important in electrical machine designs, and it's used a lot nowadays in industry to modify and make advanced electrical machines for electric vehicles, for instance. Then we will discuss the transformer. Okay. Someone claiming he cannot hear us, is it right? All of you are hearing us, Shabab?
Yes, yes.
Okay,
Yes, doctor. Yes.
So it's one separate problem, individual problem. Okay. After that, we will discuss electrical transformer and what is the advantage or main rule of electrical transformer in our grids. Then we will describe the DC machines, and we'll describe the rotating magnetic field machines, which is AC machine. After that, we'll discuss the three-phase induction motor, which is used a lot in our industry now. And finally, we will discuss the transmission line and the cables. And we can say that chapter 1, which is review for three-phase circuits, can serve electrical machines and power system. However, from magnetic circuits up till three-phase induction motors, all of these parts are related to electrical machines. And only transmission line after that is an introduction to power system. So the course is focused here more than 80% on electrical machines. Right. This is about the course content. I scrolled down this part, which is the content, the contacts, my contacts and the email. The office hour will be Sunday, Tuesday from 9 to 10 and from 10 to 11, or by appointment. If anybody has any problem, just send me an email and we can assign a meeting, inshallah. Right. طبعا الاوفيس لوكيشن والكلام ده ان شاء الله will be beneficially for the physical classes, but for now we can keep in communicate using emails. Right. The textbook will be principles of electrical machines and power electronics. The author is P.C. Sen. This book is very good book, and this author is well known, and it's easy for students as an introduction to electrical machines and power electronics. We will start from this book, and we will add some notes for the transmission line by the end of the course, inshallah. Regarding the policy, grading policy of the course, as you can see, homework will be 15 points. Quizzes will be also 15 points out of 100. Attendance is 5 points out of 100. So the class works with attendance is around 35 degrees. Laboratory will be 20 degrees also. Midterm exam will be in 22nd of October. and it will be 15 points. For the project, there will be a design project, and the grade is 5 points, and the final exam is 25. As you can see, the policy is different a bit now because of part of the class will be online. However, we expect at week number 7 or week number 8 to have a decision from the university or from the government to transform to physical classes. And we hope, inshallah, to transfer to physical class. But if we couldn't, we will continue in the same way, and this will be the fixed syllabus grading policy for our course, inshallah. There is a question.
Doctor, about the books, can you send us the books as a PDF or in the Blackboard?
Sure. It's already sent on Blackboard. Please check your Blackboard. You will find the syllabus, this outline, course outline. You will find also the textbook and the class of today. All of these are shared to you on Blackboard. Welcome.
Thank you.
Welcome.
Doctor?
Yes, welcome.
The design project will be in the lab or in the lecture?
All of these materials are related to course, not lab. Lab is 20 degrees, and your lab instructor will take care about these 20 degrees. However, all of the other 80 degrees will be related to class. Okay?
Okay, thank you.
Okay. Right, for the homeworks, there will be several homework. We will announce the dates of homeworks. Okay, طبعا you have to submit the homework as the due date, and there will be also some quizzes after each chapter. The project will be made as groups. Okay, so we will divide you as some groups. Hussein, do you have a question, Hussein? Hussein, you raise your hand. You have a question? Okay. Right. The attendance, Shabab, is very important. You have to recognize that one absent means you will lose some information from the courses, and this course is very easy. However, if you didn't follow the course and the classes, you will miss a lot. This is very important for electrical machines because all of parts are important, and it's very important for your courses in electrical engineering after that, inshallah. So as you can avoid any absence. طبعا the policy of absent, for one absent you will have a penalty of 0.5 degrees after the fourth absence. If لا قدر الله you reach to 9 absence, this will give you DN grade. So take care about the absence. Right. This is for the course outline. I shared this also to your Blackboard. Please have a look to it and read it carefully. Okay, I will share now the class of today. Any question, Shabab, regarding the course outline or the course syllabus? Right. Okay, we can start our class today, which is related to revision of electrical circuits. طبعا, I know all of you taught the learned the electrical circuits. استاذنكم شباب for the attendance, just in chat, just write present. Okay, all of you should write present for the attendance of today. Okay. We will start today, شباب, inshallah, in introduction or revision of electrical circuits. The objectives of the today class will be as follows: review for the different electrical sources. After that, review for the different types of electrical elements. What are the different electrical elements we have in our life? Then, what are the DC and AC circuits and what is the difference? After that, we will discuss the single-phase AC circuits and the power, active power, reactive power, apparent power, and the power factor. Okay. First, what is the difference between DC source and AC source, either current or voltage? Let me describe the meaning of DC. DC means direct current, which is mainly means you have only one polarity. One polarity, which means it's positive or negative. So if you have DC volt in positive sign all of time, it's called a DC. If you have DC volt or DC current negative sign for all of time, this is called negative DC source. Right. If the value of voltage or current is varying, however, the polarity still in the same polarity, positive or negative, so it's still DC current. But we can say DC current with some ripples. Okay, Shabab? So as you can see, the waveforms you have here on the left-hand side, this is ideal or pure DC. However, on the right-hand side, it's DC because it's only positive sign, but the magnitude is variable or varying along time. So it's called also DC, however, it has some ripples. For AC source or AC current or volt, the AC means variable polarity. So you have waveform with positive and negative polarity. It's transfer between positive and negative. This is called AC or alternating current. So if the source is sinusoidal waveform like the one on the left-hand side here, we call this source is pure sine wave. So it's AC and the waveform is sinusoidal. On the right-hand side, you will find triangle AC. It's AC also because we have positive and negative, and the supply itself is not pure sine wave. You know, some analysis can be made for any waveform called the Fourier analysis. It's just series. You can apply it for any waveform in order to recognize what is the component of this waveform. If you analyze the triangle waveform, you will have fundamental waveform, sinusoidal wave, and you will have some other sinusoidal waveforms with higher frequency. So if the fundamental is omega, you will have 2 omega, which is second order, 3 omega, which is third order, and so on. From second order to n order, these orders are called harmonics. So what is the difference between triangle and pure sine wave? Triangle has sine wave also, along with harmonics. Right. What are the features of the size of the AC supply we have in our rooms or on electrical grid? Is it pure sinusoidal or we have some harmonics? It's a question for you, Shabab. And you can open your mic and discuss with me. What do you think? Is it pure sinusoidal waveform or we may have some harmonics?
Pure sine.
Can you repeat the question, doctor, please?
Again, the question again. The supply, what we have in our homes, Is it pure sinusoidal waveform? الأول يعني is it AC or DC?
AC.
AC. جميل. طيب, is it pure sinusoidal waveform or
Yes.
it may have some harmonics?
It's pure sine.
No, it may have some harmonics.
May have. طب,
No, we will have some harmonic, doctor.
Yes,
We
جميل.
cannot get rid of the noise.
جميل. طب, from where these harmonics can be obtained?
From anywhere, doctor. The noise is something random. We cannot control it.
طيب, ممتاز. طبعا يا شباب يعني harmonics or harmonic sources are too much sources. It can be any disturbance, as your colleague said, and there are some definite sources for harmonics. We already know these sources. Okay, and we can describe this, inshallah, later in the different type of machines. Sources of harmonics can be the load itself, because we have linear load and non-linear loads. For non-linear loads, which almost have power electronic converters, like rectifier, like inverter, like DC choppers, all of these kind of power electronic converter modulate the supply for a certain load to have certain shape of waveform, and all of other distorted waveforms injected to electrical grid. So it can be a source of harmonic. Also, lighting. Lights is considered as one of the sources of harmonics. You know, now we have LED lights. LED lights is nothing but some LED, which is diode, connected to power electronic circuit. So it can generate also some harmonics on our grid. So there are a lot of sources of harmonics in our grid. Actually, it's a very big problem. However, we work on how to reduce these harmonics on electrical grid, also by using the power electronics. So power electronics is the source of harmonics, and also it's a solution to remove these harmonics from electrical grid. Inshallah, I mean, if you take the course of 460, you will understand in details what are the types of power electronic converters. And by the way, it's very important in our life, Shabab, and in modern applications. Yani no renewable energy can work without power electronic converters. No electric vehicles can work without power electronics converters, and so on. Fine. So this is just introduction for the different types of sources. So now we agree the sources, what we have in our homes, are AC sources. However, it contains some of harmonic contents along with the sinusoidal supply. Here in Saudi Arabia, we have 60 hertz fundamental frequency. In some other areas, we can find 50 hertz fundamental frequencies. In some other loads around the world, you can find 400 hertz. Okay, so we have many standards for frequency according to the load type. However, most of the world are working with 50 or 60 hertz. Right. What are the different electrical elements we use in our loads and in our industry? We have two kinds of elements. We have active elements and the passive elements. Active elements, it means there is an interaction between the circuits according to the applied control. This is like switches, like MOSFET, like IGBT, like BGT, and so on. These are electronic switches or power electronic switches. This is called active element. However, the passive elements like resistance, like inductance, like capacitance, these are the main electrical elements we use in our life. So we have passive and active elements. Active elements are controlled elements. Passive elements are like R, L, and C. So what is the nature of each element? What is the nature of resistance, nature of inductance, nature of capacitance? You know, in DC circuit, if we assume ideal DC source, which means current is constant and the voltage also is constant. So if you apply voltage source DC to a resistance, you will have a DC current. This DC current, according to Ohm's law, I equal to V divided R. However, for inductance and the capacitance, you know the relation between voltage and the current in inductance, V equal L di by dt, which means the differentiation of current. Now, if the current is DC constant, what will be the value of differentiation? It will be 0. Is it right? So the voltage will be 0. 0 volt means short circuit. So inductance in DC can be substituted by short circuit. This is in steady state or pure DC supply. For capacitance, you know IC equals CdV by dt. Similarly, if the voltage is pure DC, so the current will be the integration of, the differentiation of the DC voltage, so it will be 0 as well. So if the current is 0, this means the circuit is open, there is no current flow. So the capacitance can be removed from DC circuit or steady state circuits, steady state DC circuits, and replaced by an open circuit. This is for DC. For AC, all of the elements are exist. Resistance, inductance, and the capacitance. Resistance, the load of resistance, like for example, the heaters, okay, شباب, like tungsten lamps. This is an example for resistive load. Inductance used in motors. Capacitance used in electronic devices. All of these are electrical elements, can be used in AC circuits. But what is the behavior of all of these elements? If we have volt across the resistance, شباب, as you can see, this is the waveform here, the voltage in red color, and the current is in black color. Is there a phase shift between voltage and the current, شباب, for resistive load? شباب, is there a phase shift between voltage and the current waveforms?
No.
No phase
zero
shift.
phase.
Zero phase shift, exactly. Which means current and the voltage in resistive load are in phase. For that, you will find here the phasor diagram. V and I are in the same direction, which means V and I are in phase. In that case, the difference between the voltage and the current angles will be 0. This means the power factor, which is cosine the angle between voltage and the current, cosine 0 equal 1. So for resistive load, the power factor is unity all of time. This is for resistive load. For inductive load, as you can see here, we have inductance. If we apply voltage across the inductance, a current will flow lagging the volt by 90 degrees. As you can see, this is the voltage waveform in red color, and the current appeared lagging the voltage by phi, and this phi for pure inductance should be 90 degrees. However, in our life, there is nothing called the pure inductance, because inductance is nothing but coil or wires. These wires are wound across a core, maybe air core, maybe any magnetic material core, as we will describe inshallah in magnetic circuits. So the wire itself has its own resistance. So the inductance or the inductor has an equivalent resistance. The same is also for capacitor. Capacitor also we have series equivalent capacitance, resistance. The capacitor itself has series equivalent resistance. So there is no ideal capacitance or ideal inductance in our life. So this phi should be less than or equal to 90. For ideal, it's 90, and for actual, it's less than 90 degrees. The same also for capacitance. If you have capacitance and you apply a voltage AC, you will find the current is leading the volt by 90 degrees. And the same also, we can assume it's phi here because there is no ideal capacitor. So for inductance and the capacitance, if it is ideal elements, the angle will be 90 degrees, and the cosine phi, which is the phase shift, cosine the phase shift between V and I is 90 degrees, so cosine phi will be 0. So for power factor for inductor case, it's 0, and we call it lagging because the current is lagging volt. And for capacitor, pure capacitor, the power factor is 0, and 0 leading because the current is leading volt. Any question, يا شباب? Is it clear?
Yes, yes, it's clear.
Okay, it's good. Please, if anyone has question, instead of raising your hand, you can operate your mic and ask, because you are 30 students and it's not easy to go to the list to see if there is anybody has any question. شباب. For a single phase circuit, شباب, assume we have a circuit like that with RL load, and we have supply of AC. V at angle 0 means we have reference volt, or the volt is assumed to be a reference vector. So if we represent V in phasor diagram, as you can see, this is V and the angle is 0. And we have R and L. طبعا inductance شباب measured in A. What is the units of inductance?
Henry.
Henry. جميل. Is it possible to apply Ohm's law to Henry? يعني can we say V
No,
equal Li? Is it
No,
possible? It's not possible. Because يعني it's called Ohm's law. Ohm's law, so the impedance has to be in ohms. Like, what is the ohmic value of inductance? Firstly, it's called the reactance. So the ohmic value of inductance is called reactance. So we have inductive reactance, which is the reactance of inductor, and we have capacitive reactance, which is the ohmic value of capacitor. ماشي شباب؟ For the ohmic value of inductance, reactance equal 2 by FL. 2 by multiplied by frequency multiplied by the value of inductance. تمام يا شباب؟ For the reactance of capacitor, XC equal 1 divide omega C. تمام؟ This is the relation of the reactance. So in our case here, we can say Z, which is the impedance, equal to R plus JX. In case of capacitor, it will be R minus 1 divide omega C. تمام يا شباب? Or R minus JXC. طيب, this is the impedance value. But if we assume the source of V equals square root of 2 multiplied by VP, and VP here is the root mean square supply voltage, multiplied by sine omega t. Do you know what is the meaning of RMS? Anybody can discuss for us what is the meaning of average and RMS values?
Root mean square.
Okay, I mean the RMS abbreviation is the abbreviation for the root mean square. But what is the physical meaning of root mean square? Yani why we do not use average value in AC supply? Hey شباب. طب let me ask you a question. If you can, and if you have a look to the voltage waveform here, V, as you can see, it's sinusoidal waveform, is it right? With a big value called V maximum, okay? What will be the average value for a complete cycle from 0 to 2 pi? What will be the average value?
0.
Are you agree, شباب? 0?
Yes.
Because the average means the summation of area under curve. So the positive area and negative area are the same. So the average will be 0. But is the average value now as an expression can be used for AC supply? Yani you have already a voltage magnitude. The voltage magnitude of your socket at home is not 0. If you measure the voltage using any multimeter, any voltmeter, you will find a value. So what is the value? How this voltmeter can measure a value.
It's the RMS value.
What is the meaning of RMS? This is the meaning.
the
RMS.
average DC power. The average DC power.
It's related to the power, or it's coming from the power. This is right. But what is the sequence? How we can, or what is the meaning of RMS? And if you have now a sinusoidal waveform like that, first, if you apply square, this means the positive half cycle will be squared, and the negative half cycle will be squared and converted to positive. Is it right? ماشي شباب؟ يبقى if we square the waveform, both positive and negative cycle will be squared and will be positive. After squaring, you can take the mean value, which is the average value. In that case, you will get the average value of the voltage waveform, but after squaring. So in order to get the effective value, you need to take the square root again. So we first make square, then we take the mean value, then we make root again. So it's called root mean square. So this is just a way to get the effective value of AC supply. Okay, شباب? Because in AC supply, you cannot take the mean value. طيب. For that, the RMS value for any sinusoidal waveform equals to the maximum value divided by square root of 2. For that, for any time domain waveform, you can express the voltage as V maximum sine omega t, which is square root of 2 multiplied by V root mean square sine omega t. And also for I here, you have square root of 2i root mean square sine omega t minus theta. If you would like to get the current as a function of voltage and the impedance, so first you get the impedance Z equal to square root of R square plus X square, and the angle theta equal to tan inverse X divided R. So now you have the vector of Z, magnitude value of Z at angle theta. So if you would like to calculate current, simply you can say I equal V divided Z, and the magnitude will be V root mean square divided Z, and the angle will be minus theta. So this is the current expression. The phasor diagram, شباب. Here we agreed together the voltage is at angle 0. The current, as you can see, it's at angle minus theta, so the direction of current will be in this direction. This is the minus theta direction. And we add current on phasor diagram just for direction, not as one of the parts of the triangle. Okay, شباب? Not as one of sides of the triangle. Sides of the triangle, all of time here will be voltage vectors, not current. Amen? So we agreed together that the resistance, the voltage across the resistance will be in phase with current. Is it right? So if this is the direction of I, the direction of IR will be the same. So this is IR. If you add the voltage across the inductance, which is equal to Jx multiplied by I, J means 90 degrees in positive, so it's counterclockwise by 90 degrees, counterclockwise of the current direction by 90 degrees, and the current multiplied by the value of X. So this side represents Jix, which is the voltage across the inductor. The summation of the two vectors, voltage across the resistance plus the voltage across the inductance, will give you the resultant voltage, which is the supply voltage. So this is the phasor diagram of this circuit. Okay. If you would like to calculate the power is nothing but V multiplied by I. So if you multiply V by I, you will have V, which is Vp multiplied by square root of 2 multiplied by sine omega t, multiplied by current, which is square root of 2it multiplied by sine omega t minus theta. So the resultant will be 2Vpit sine omega t minus theta. You can replace this multiplication of sine omega t multiplied by sine omega t minus theta by this expression. As you can see, we have three parts. This part, which is called P1, and this represents the average value of the power. This one represents the VPIB cosine theta multiplied by cosine 2 omega t, which is double of the supply frequency. And this one also multiplied by sine 2 omega t, which is double of the supply frequency. This is the power. This is the instantaneous power. If you would like to obtain the absorbed power, which is the average power, you will only consider this term, because the second and third term average value will be 0, because it depends on the twice of the frequency type. So the real power or active power will be represented by P1, which is V root mean square, I root mean square, cosine theta, where theta is the angle between voltage and current. The other term is P2 represent the ripples in instantaneous power, and VPIB sine theta, sine 2 omega t, it's function of sine theta, take care. This part will represent the reactive power. So if we have a look to these waveforms, this is V, and this is I in case of inductance, and this is the multiplication. This is the instantaneous power, which is the sum of the three terms. And the three terms, this is B1, which is constant value or average power, or called average active power. And if you add P2, which is the ripples in instantaneous power, and add it to the average power, you will get this waveform. So this is the instantaneous real power or active power. However, when you work in equations or calculations, we calculate only the average, and the average of B1 plus B2 will be the same like B1, okay? Because B2 is just some ripples. However, B3 as instantaneous power are representing the reactive power, which is Q. So we now have two main parts of apparent power. Apparent power is the total power. Total power is nothing but B and Q. B can be calculated by VBIB cosine theta. Q can be calculated as VBIB sine theta. And power factor is the cosine angle between voltage and current. So the equation of the apparent power is equal to V multiplied by I conjugate, which is equal to P plus JQ. As you can see here, shabab, this is called the power triangle. This side is P, which is the active power, and this side is JQ, and here JQ is inductive, so it's positive. If the Q is coming due to capacitance, it will be in negative, will be minus J, okay? And S represent the apparent power. Shabab, the value of theta, if the value of theta is 0, what will happen to the value of Q? Hey, Shabab, it's a question for you.
It will be 0.
It will be 0.
Exactly. This is right.
Real
because
power.
the power factor will be unity, and in this case, the apparent power will be equal to the active power. For this, Shabab, the electrical company makes penalties on factories that have small power factor, and the urge factories to reach to unity power factor, because if it's the power factor is unity, it means the S will be decreased up till reaching to P, and this is going to save the current and the cables for electrical company. This is the reason why the electrical company makes penalties on factories and need all of time to improve the power factor. We will discuss in details the power factor in the chapter of synchronous machine. Here is a simple solved example. We have a voltage with this equation. Okay. This is the voltage equation, 240 sine omega t plus 60. So the volt here at angle 60, it's not at 0 angle. I equal to 5 sine omega t minus 10 ampere. المطلوب يا شباب find the values of the average power, absorbed power, and the power factor. Sorry, find the value of average power absorbed by the circuit. طبعا average power absorbed by the circuit is going to be absorbed by resistance or inductance?
Resistance.
Resistance, sure, because inductance is not taking active power. Okay, شباب? So simply we can substitute in the relation V equal V root mean square I root mean square cosine theta V minus theta I. V root mean square equal to V maximum divided by square root of 2. And similarly, I root mean square equal I maximum divided by square root of 2. Multiplied by cosine theta V minus theta I. So you can simply get the active power value. The power factor is simply cosine the angle between V and I. It can be calculated in another way. If you calculate the impedance, but here it's not calculated. Let's describe it in the next example. And we can say from the triangle here, we can calculate the power factor angle, which is theta, by using cosine inverse B divide S. Is it right? Or we can call power factor, which is cosine theta, equal B divide S. But if you divide this phasor diagram by I, so it will be here R instead of, sorry, I squared. Will be here R, here Q, and here Z. So it can be calculated also from the impedance triangle. R represent P, and X represent Q, and Z represents S. So we can say it's R divide Z, which is giving the value of power factor also. The power factor can be calculated as cosine theta V minus theta I, but you cannot say the value only. You have to also identify the type. Is it lagging or leading? Here, يا شباب, because it's an inductive load. Why it's inductive? Because the voltage is, or the current is lagging the volt. So the power factor is lagging. Okay, شباب. Any question? Last examples. Solenoid coil with resistance of 30 ohms and inductance of 200 millihenry is connected to 230 volt AC, 50 hertz supply. Calculate the solenoid's impedance. How we can calculate the impedance, شباب? We said we have R and L. So R is 30, L is 200 millihenries. So we can calculate the reactance, which is equal to 2 by FL. So simply we can get the value of reactance. And impedance equal to square root of R squared plus XL squared. So this is the impedance. Second, find the current drawn by the solenoid. You have the impedance and you have the applied voltage. So simply you can say I equal V divide Z and get the value of current. What is the phase angle, which is the angle of power factor? It's simply equal to tan inverse X divided R. You have calculated X and R is given, so you can simply calculate the angle. Next, what is the power factor? Power factor equal to cosine angle of impedance, or angle between voltage and the current, which is the same. Or we can say it's R divide Z, it's the same. Right. Last, what is the power factor? Sorry, this is a typo error. And the average power consumed. Power factor we already calculated. Average power consumed, so we can say T equal V root mean square I root mean square cosine theta V minus theta I, and give the value of power. In another way, you can say it's equal to I square root mean square multiplied by R. It will give you the same value. Right.
Doctor,
تفضل.
why is it lagging?
Because it's inductance.
Okay.
We said for
Yes.
inductance case, all of time current will lag the voltage. Okay. Now let's solve these questions together. What is the maximum value of power factor, شباب? Is it 0.5, 1.5, 0.95?
1.
Please write your answer now on chat, but not A, B, C, D. Write the value, 0.5 or 1 or 1.5 or 0.95. Great, يعني most of you wrote 1. طيب, is it possible to increase the power factor over unity? Is it possible يا شباب؟ طبعا no. طيب, I will ask you a question and you should prepare the answer of this question by next class إن شاء الله. If you have a load and the power factor of the load is equal to unity, and you add capacitor to this load or across this load, what will happen to the power factor? You know, to improve the power factor, we add capacitance because most of loads are inductive loads. Most of loads in our life are inductive. So if you add capacitor to the circuit, what will happen to the power factor if the power factor were already unity? Okay, يعني think about it and we can discuss inshallah next class. Fine. The second question, active power and apparent power are respectively represented by, what is the units of active power and apparent power? شباب, is it A, B, C or D? Write your answer also. We have A, C. Someone wrote KVA, كبار. مفيش حد بيه خالص؟ ليه كده بس؟ زعلتوني. ماشي خلاص، انا قلت دي خلاص. طيب شباب, يعني الاكتف باور is measured in what? صح؟ So the kilowatt is the measure of active power. The apparent power, we said S equal to VI. So it's expected to be volt ampere or measured in volt ampere. So it's KVA. So the right answer is number D. صح؟ طيب.
Doctor, we are used maybe to real power, not active. It's maybe the terms we are using.
طيب, يعني احنا بنشرح دلوقتي, قلنا يعني the active or real power are the same. Active power, real power, average power,
yes,
all are the same meaning. Okay. The only meaning for the imaginary power is reactive power. So it's called reactive or imaginary. تمام? The total power or the vector of the power is called apparent power, which is S. تمام يا شباب؟ طيب. Power factor can be improved by connecting which among these? Static capacitors, resistors, synchronous condensers, both A and C. طيب تمام, هو في ناس كتبت A وفي ناس كتبت D وفي D كتير. طب دي طبعا اللي هي both A and C. طب ليه يا شباب A and C? What is synchronous condenser? Do you know synchronous condenser? الشباب اللي قالت D. You can turn on your mic and discuss with me. Huh?
I think they are work just like the inductors.
مش inductor, قصدك بقى condenser. صح؟
Yes, condenser, but
تمام.
they,
this part إن شاء الله will be covered in details in synchronous machine. ماشي? Because synchronous condenser is a synchronous motor operated at a certain condition. Okay, so it can be used, and the right answer here is D. Okay يا شباب. يعني this was the first class, and this is the summary. We have covered these items. يعني the time is due now. If anybody has any question. Any question يا شباب؟ الكلاس شباب, I have uploaded the class, this file, and the syllabus, and the textbook. All of this you will find it on the Blackboard.
What about the recorded session, Doctor?
I will upload it also by evening, inshallah, this evening.
Okay, thank you.
Okay. Any questions, شباب? Okay, thank you all, and see you inshallah next class. Yeah. Assalamu alaikum.